Heidi ho, math geniuses. All right, we're going to be solving in this unit, lesson 6, a whole bunch of systems, not just linear, but we're also going to go into the nonlinear. So things like parabolas, quadratics, your absolute value, maybe something that's a little curved like this, exponential, maybe square. You never know what we'll get. But it's not a big deal. You've got that graphing calculator, and we're going to be able to solve these babies without a problem. All right, let's begin. All right, here we go with exercise 1 here, okay? Bottom line in exercise 1, they want us to solve this equation up here the old-fashioned way. Well, I went ahead a little bit, so feel free. Remember, I go like rocket ship. Pause the video as needed and fill this in. But the bottom line here is I started off with moving this x right here to the other side. So I got 4x minus 2 then equals 10. Turn around, move the 2 to the other side since all my x's were now on the left. Then if you follow my pattern up here, I was left with 4x equals 12. Divided both sides by 4, and my answer is equal to 3. I think you'll like that much better than me trying to write by hand in that small little space, okay? But we've got that all in there, and we solve it. You're supposed to check it. If you go back and you check it real quick, 3 times 3 is 9, minus 2 is 7, and 10 minus 3 is also 7. So it does work. You're supposed to show it on your paper, though, okay? Now in part B, actually, they want us to fill out the table. So if I go to the table here, you're supposed to take this one right here and this one and plug it in. So if I plug in 0 first into this one right here, I actually get 3 times 0, which is 0 minus 2, so I get a negative 2 right in that spot. If I plug in 1, I get 3 times 1. You guys know that's 3. 3 minus 2 is equal to 1. If I plug in 2, 3 times 2 is 6, minus 2 is 4. I plug in 3, 3 times 3 is 9, minus 2 is 7. And 3 times 4 is 12, minus 2 is 10. That's the first row. The second row, 10 minus 0, of course, is 10. 10 minus 1 is 9. 10 minus 2, 8. 10 minus 3, 7. 10 minus 4, 6. And we've completed that by filling in the table. Remember, this is also you could use your graphing calculator and you could throw this first equation into the y equals this one right here, and you could put this in for your y2, and you can get your table right off that graphing calculator. So don't be afraid to do that. Well, in part C, they actually do want us to. They said, using your calculator now, sketch the graph of the 2 and take a look at what it looks like. Now, they also talk about your window, what you're supposed to set it as. Mr. Payne, Miss Bell, and I will talk about in class. But bottom line is we just want to take a look at this thing. And I'm going to snap on a line here. Actually, we'll go this way. And if I take a look at the 1 equation, and it starts off at 0, it's down negative 2 here. It actually starts off way down here, and oops, let me put the point here. It starts off down here, and it actually goes up pretty steep up this way. So I'm going to snap a line onto this one and draw a line. Looks something like that, okay? The bottom line is if you do the other equation then, at 0, you know how that turned out to be equal to 10, so that's up here somewhere. And it actually goes down, and at 4, 6, etc., and it keeps going, and it actually comes off the chart depending where you want to go. And I will snap a line that way, and you might have something that looks like this. So the two graphs look like this. Well, they want you to figure out the solution. Well, once again, the solution is right where those two hit. So if you take a look right here, it's right where they hit. I'm trying to draw an arrowhead. That's your solution at this point right here, okay? Well, you can look on your calculator to see what it is. There's all kinds of methods. Or if you take a look over here, guess what? There's your answer in the table, 3, 7. And we already tested that back out here when x was equal to 3 in the first part. So they're all coming together, showing you the same darn thing, okay? All right, part D on here. Last piece on this one says to solve the equation f of x is equal to g of x. What did you do? You have to graph both. So we had to graph them, both the two together, and find what is that thing called right here, back over here. What's this called? That's the point of intersection. So everybody should write the word intersection in their notes. Okay, that's the whole key out of all this. Whenever we're graphing two systems of equations, one method is the graphing method, and where those two babies cross, that is your solution, bottom line. And two lines can only cross once. They can't cross more than once, okay? All right, we're going to move on to the next question. All right, in this exercise 2, they want you to basically consider this equation right here. I've basically got, you should be starting to recognize that's a quadratic because of the square there. And this is linear on this side. And so once again, we can actually go and graph these two. Yes, we're going to learn how to do it eventually algebraically, more than one system, okay, with a quadratic. But we're going to graph the two. Well, for you, I would go in your graphing calculator right now, put this one under y1, okay, so x squared minus x, get a table of values, and put this one under y2 and get that system table of values, okay? And pause the video, and I want you to graph this thing. Do a sketch of the graph. All right, if you haven't paused it, you better pause it quickly, but here we go. Bottom line is, if you put in a bunch of points here, I'm going to take a look at this, you should get a U-shaped curve that looks something like this. Comes way down here, comes back up like this, and you're going to get a line that actually crosses a little bit above here, crosses over here, and is going to cross again down here. So if I snap a line on again, this time go this way, you should have a line that goes through something like that. Well, how many places did they intersect? Well, there are one solution's right there where the two, it's a parabola, the quadratic and the line hit, and the other solution is up here where they hit. So those are your two solutions. You can go to your graphing calculator, and if you look under your table, you had your x table and then your y1 and your y2, okay? The two key points are going to be this. At -5 for the x, this turns out to be 14, and this one turns out to be 14. You also have another one at +3. Up the table, you will get -2 and -2. So these are your two solutions, -5, 14, and that. And once again, we'll show you in class, but all you have to do is read off the graphing calculator just like two lines. There's nothing new here. You should not be afraid of a quadratic, okay? And then obviously you can test them by plugging them back in. All right, moving on to the next one. All right, in exercise 3 here, we are going to deal with a function you're not as familiar with, although you've seen it a little bit, and that's function of f of x is equal to 2. These are those absolute value bars, okay, of x plus 1, subtracting 8. Anything you have, you can throw into y equals. Remember, f of x is the same thing as y equals, and we can throw it on that graphing calculator, get points, no problem, and all that. The key on absolute value, you're going to see in a moment what's going on here. So it says, and this is an absolute value, typical V for value, from the absolute value one. So we're going to look at this. It says find all the values where x is solved in the equation below. And you can go and solve this thing all you want and get the answers. That's fine. It's a little trickier. That's a little harder concept. But the graph is pretty easy. All you got to do is see where the thing hits the x-axis here. One right there, one right there. So if I'm writing this down here, one is -5 to the left, and the other answer is 3 to the right. So you got right here, and you got right here. Those are your two answers. And if you plug them in the equation, it will work. Trust me, take your moment, try it on your own. All right, and part B says, find all the values of x that solve the equation when this happens. Okay, and all you'll see that's different is this piece right here. It's the exact same equation as we just had right up here, except they put a -2 on the side. Well, when it's y equals, this has to be equal to 0 in order to throw it in the calculator. So all you have to do is add 2 to both sides. So your equation changes to this. You got 2 times the absolute value of x plus 1. And the 2 obviously goes with the -8, so that's -6 equals 0. That's the one you put in the graphing calculator. Well, I'm going to give you a quick clue here on this one. And if you look at your points on there, it actually shifts this thing up. Even though I know it says -2, you shift it up 2. So this thing moves up 2. And this point like here goes up 2. It hit right there. And this point here goes up 2, etc. All these points go up 2. This one will move up 2. This one here moves up 2. This one here moves up 2. All those points. So you will see that the line now looks like this. And this side is going to look like this. And here are your two new solutions. And all they did was, even though it moved up 2, it shifted, if you look like inward, 1 each way. So instead of -5 to the right, my answer now is -4. And instead, or sorry, to the left. And instead of 3 to the right, it's only 2 to the right. Those are your two answers. I should put an and here instead of the comma, okay? That's what you do. All right, we're going to keep going on with this equation on the next page. All right, in our last part of this exercise, you will see, it says find all the values in this equation. There's a little more work, it says. But guess what? You already did this part. Isn't this piece right here, the V right there? That's already over there, okay? So what do you have to do? You got an equal sign there. So all you have to do is change colors here. Graph this piece. That's basically y equals x minus 1. Your m is equal to 1 out in front of the x, and your b is equal to negative 1. So all I have to do is start down 1, and then my slope is 1 over 1. So go up 1 over 1, up 1 over 1, up 1 over 1, etc. And keep doing this, or down 1 to the left, and you will see this is what you do. I'm going to snap a line onto this just so you can see it here. And bingo, here we go, solutions. Where do they cross? I think I might be off a little bit on my one. It should be this one right here, actually, and this one right here. So if you want to know your solutions in this case, on the two, where they're going to go, they actually hit at those intersections. So one solution looks like negative 3 to the left, and I am down 1, 2, 3, 4, so negative 3, comma 4, okay, is the entire solution. And if you look at the other one, it looks like 1, 2, 3, 4, 5 to the right, up 1, 2, 3, 4, 5, 4. If they just want the x part of the answer, then obviously your answers are negative 3 and 5 that plug into this original equation up here, and you can check them, and they will work. So it's kind of a neat way that I never actually thought of until this year, was taking the two sides and graph them both, see where they intersect. And once again, you've got that graphing calculator. Don't be afraid to punch those in and get your y equals and get your tables if that's the way you want to do it. All right, one last question. We're going on to number 4. This last question is pretty straightforward, pretty easy. You got two functions here. One is y equals negative x squared plus 4x. That's a parabola. That will be this U-shaped one. And you got a linear one right here, and they graph that line right here. They want to know where your solutions are on this grid. Okay, pause the video for a second because I think you can handle this on your own. By the way, they put the two together right here just like that. But it's all graphed for you. Figure them out. Give a second. I'm going to hold up for you. All right. I hope you figured out that they hit right here and right here. So if I mark those off, those are our solutions right here and one right there. Well, where are they? The x is over 1 right here, so one of them is 1. And the other one, count over 2, 3, and it hits at 4. Those are your two answers. Bingo. Choice 2. All good and going. And that's all you're doing. You guys can do this stuff on a graphing calculator, punch it in, have confidence, roll with it, okay? Write us a nice WSQ. Talk about that graphing calculator, how it helps you. What can you look at? The table, the intersections, the pictures, and all that. All right? It's a nice way to go, and we're going to keep moving on in this unit. See you tomorrow.